All right, guys, so we're going to talk about another characterization of compactness. It's still not the most general one, but I don't want to go too far into the weeds. So if you guys are looking for a finite subcover definition, this is not the video for you. So we're going to still stay on the real line just to help build intuition. We're just going to add the subsequence definition, which will be true on complete metric spaces. Actually, I'd have to look that up again. Forget what I just said. They might have to still be finite dimensional. I'd have to think about it a little bit longer. So X is compact if and only if X is closed and bounded. If and only if every sequence in X has a convergent subsequence with the limit point of that sequence in X. So what that is saying is for every xn sequence contained in X, there is a subsequence with for some X. So A, it's convergent, and X is indeed in X. So going back to that example, where we're looking at prices, if our space X was untaxed prices, then it was compact because when we took that sequence and we found the limit point, it gave us a valid price. But if we looked at Austin taxes at 8.25%, and we thought about X as being still the same space of prices, but I took that sequence of tax prices, then I didn't get a valid price back out. So it wasn't in the space X. Something weird happened at infinity is basically what happens. Each one of these xn's is in X, but when you take sequences, you can lose properties at infinity to some extent. So similar to how when you take a sequence in R, and you take something that goes to infinity, you just call it divergent because infinity is not a number. Something weird happened because you did some infinite process. So, just as an aside, if you haven't seen this, I guess not an aside, it's crucial if you haven't seen subsequences before. So a subsequence is a subsequence is you pick out indices. So let's say that xn is 0 when n is odd, and 1 when n is even. So clearly, and you can think about this if it isn't clear to you, this is not a convergent sequence. You're bouncing between 0 and 1 a bunch of times. So this is the sequence 0, 1, 0, 1, 0, 1 forever. It's not, it doesn't converge. But there's a subsequence that converges. That's what's important here. So xn is a subsequence if nj plus 1 is greater than nj for every j. So for example, so basically what you're doing is you're picking the index at j that you want out of the original sequence. So if we're going here, I'm going to say two natural subsequences to take are x and x2j. nj is a function of j, and it's strictly increasing, so that you're actually going all the way out to infinity. If I chose to just stay, if I repeatedly picked the 0 or the first index over and over again, then you're not really seeing what the limiting behavior is. That's why this has to be strictly increasing in j. So this subsequence would say when we're even. So we're picking y1 is x2, which is 1. y2 is x4, which is 1. y3 is x6, which is 1, and so on. So this sequence would actually look like 1, 1, 1, 1, 1, and so on. Another natural one to choose is odd indices. So this is x2j minus 1. So y1 is x1, which is 0. y2 is x3, which is 0, and so on. y3 is x5, which is 0. And so this actually is the constant sequence 0, 0, 0, 0. And you could do anything imaginable. So you could choose y1 to be x1, y2 to be x80, y3. Okay, but you can't go back to anything less than 80, less than or equal to 80. So y3 has to be like x 103. y4 is x 105. y5 is x 6001. y6 is x 6002, and so on. So subsequence, you have tons of freedom as to what you can pick as long as it's increasing, so that you actually go out to infinity. So yeah, I mean, you can even, a sequence is the sequence itself is also a subsequence, right? Taking the sequence 1, 2, 3, 4, 5, 6 is increasing. So it's still a subsequence. So what this is saying is even if you don't converge, okay, we're going to stay on this example for a little bit longer. 0 when n is even, 1 when n is odd. I guess I made a mistake earlier. Let's make sure it's consistent. Oh, 0 when n is odd, yeah. Okay, I didn't make a mistake earlier. So we start at 0. Okay, so the motivation behind this is, look, this clearly doesn't converge, right? It bounces between 0 and 1 tons and tons of times. But honestly, dude, like, it kind of converges to 1, it kind of converges to 2 if you pick the indices correctly. Right, so that's the motivation behind this. This sequence is way worse. Oh no, it would still converge. It would still have the example I was writing would still have a convergent subsequence. Namely, you just pick the zeros. This one wouldn't. So this has no convergent subsequence. So yeah, so this one does have a convergent subsequence, and we built it earlier, right? if I just choose the even indices, well, I'm just going to see 1. And clearly a constant sequence of 1s is convergent, namely to the limit 1. Similarly, if I just choose the odd indices, clearly converges to 0 because I only get 0 back out. So this has a convergent subsequence. This does not. If I choose y sub nj to be any, yeah, this is something you eventually get used to. So I'll go ahead and label it x and j. For arbitrary sequence nj. And also, if this is new to you, you can think about it, these basically mean the same thing. N is a function of j, is another way to think about it, and it's strictly increasing. Because you still need nj to go to infinity. So if we pick any arbitrary subsequence, well, that means that yj is less than or equal to, well, the smallest is going to be as n if it's odd, and the biggest is going to be as 2n. Let's do something. Oh, sorry. Yeah, I'll have to edit this out. So, because I called this y. So let's keep y there. Yeah, let's keep y there. I know y. Actually, let's change y. Well, let's say it's 0 when n is odd. So this one is just n. We didn't need to do that complicated of an example. So let's consider wj is znj. Well, then this is just nj. Now, since nj is strictly increasing, that's greater than j. And because this function is an increasing function of n, that's greater than j, and that goes to infinity. So that tells us that any subsequence doesn't converge. And so this would tell us that the set of all n is not compact. It's another way to look at it. Also, it's clearly not closed and bounded. It's not bounded. So, and then if we return to this example where I said yn is 0 for n odd, and it's n, it's just for consistency, n even. This one does have a convergent subsequence. Oh, okay, wait 1 second. Okay, yeah. This does have a convergent subsequence. Yes, this is the example I wanted. Sorry, guys. So that is because if I pick, let's use w again so wj to be y 2j minus 1. Then I get a constant sequence 0, 0, 0, and so on. Okay? And this is, I guess, how I'll end the video with this question. is the sequence, the set is that sequence compact? You can pause the video here and think about it. The answer is no. And you'd say, okay, well, but Tyler, you just showed me a convergent subsequence of y, and you can clearly just take them all equal to 0. But remember, that is not what compactness means with this other definition. Clearly, you can show me that it's not bounded, right? So your intuition with closed and bounded should also tell you that I was pulling a fast one on you. So for all sequences, there is a convergent subsequence. So So the point is we have a for all sequences here. So namely, if I now choose Wj is Y2j, then this is the sequence 2, 4, 6, 8, and so on. Okay? So and this is a sequence contained in the set. Yeah, so so now we're going to take a sequence of a subsequence to some extent. So let's call it PK, just to be, is W WLK. Well, WLK is greater than or equal to 2LK, which is greater than or equal to 2K. And that goes to infinity. So in particular, the sequence Wj has no convergent subsequence. And so that would tell us that the set A, well, A equals this. A is not compact. So that's, when you use this definition, remember that it has to work for an arbitrary sequence, not just one. Yeah, and so that should conclude compactness here. Let me know if you guys want any other videos, if you guys want me to go through finite subcovers and things like that, or if you want other examples. Thanks.